So first question here requires us to, draw the structure of the monomer molecule from this polymer. So polypropene is an example of a polymer. The structure of polypropene molecule is there. So that's polypropene. So what this means, this picture, means that we've got bonds going out side to side here, and that means those are linked to more of this structure. That N represents there are a certain number of these linked together. So this polymer is made from this polymer is made from a monomer. Draw the structure of the monomer. So this is an addition polymer, and this is formed from an alkene. So all you've got to do here to go back to the monomer is draw two carbons with a double bond in the middle, because it's this double bond here that is broken to form this single bond here and then the two trailing bonds either side. So all we've got to do now is just draw our four things that are around the outside of our carbons. So just put the bonds in just as they are up there, but just don't draw these two trailing bonds because they have reformed this double bond to make the monomer. Okay, so figure 7 shows a molecule of each substance A, B and C, that they are. Name substance A. So substance A has 1, 2, 3 carbons in its chain, so that's going to be prop. So remember, monkeys eat peanut butter is how you remember, or how you can remember the names of the first 4 chains of carbons. So it's prop, but there is a double bond here, so it's propene is the name. And then moving down, so substance B reacts with bromine in an addition reaction, complete the balanced equation. So an addition reaction means there's only one product. So the two things, bromine and this substance here, will react together to make one product. So first we're going to put the bromine in. So you don't have to draw it with all the bonds, but you can do. So it's Br2. And what Br2 does is one bromine will join on to each carbon that's in the alkene. So this double bond here will break and will just form a carbon-carbon single bond. Then you've got your 4 things around the outside. So that's a CH3. You've got this CH3 as well. You've got this H. And you've got this H. And then you've got the Br2, which joins on either side like that. So that is your product. And it says substance C can be used as a monomer to form polymer. There it is. Okay, draw a diagram to show part of the polymer molecule formed from 2 molecules of substance C. So it's asking you specifically to join 2 of them together. So we're going to have 4 carbons in a row, 2 lots of this double bond here. And then we're going to have this H on the first carbon of each of those. You're going to have a Cl on the second carbon of each of those. You can have this H here on the first carbon of each of those, and this H here on the second carbon, like that. And finally, because this double bond isn't there anymore, you've got bonds going out either side, like so. Okay, so this next question is about a condensation polymerization. So the repeating unit of a polyester molecule is shown in figure 6. There it is. The polymer is made from 2 different monomers. Draw a molecule of each monomer showing all covalent bonds. So this is formed, and water is also formed as well. So we've got to put back in an H2O molecule, and to do that we're going to add OH to one of them and H to the other. So where these were joined is here. So this bit here is going to form one of my, work out what's on the end of those in a second. That's one of my monomers, and the other monomer comes from this part here. So we've got an OH to put in. So this OH here will go here and here to form a carboxylic acid, and this H will go here and here to form an alcohol. And those are my 2 molecules. Give the name of enamel formula of a small molecule form and the monomer molecules react to form an ester link. So this is your ester link here that's joining these two molecules. Now this is condensation polymerization. So remember what I said, that water is the small molecule that is formed when those monomer molecules react. So we've got a 6-mark question here. It says polymers are addition or condensation polymers. Polymers can be formed by using the monomers shown in figure 12. There they are. Explain using appropriate monomers from figure 12 how different polymers can be formed. So this top monomer is an alkene, so that would undergo addition polymerization, whereas these two are a diol and a dicarboxylic acid, so these would undergo condensation polymerization. So let's start with the addition polymerization. So for the addition polymerization to happen, chloroethene double bond will break, and then many chloroethene monomers will link together. And it probably wouldn't harm to draw a diagram or a displayed formula of what that polymer would look like, and that's what polychloroethene would look like. And then your ethane 1,2-diol and ethane dioic acid would join, forming water as well. Okay, and again, a diagram wouldn't go amiss. So you've got this OH here, and this H here will go and form water, which leaves us with just this bit of the molecule, and we know that both OHs will go because this also needs to go off and join onto other things, and the H in this OH will go as well to form water. So what we'll have first is the C double bond O, C double bond O, and that's going to join onto this here up to the O, because just the H is gone. It's going to join onto O, CHH, CHH, O, and then that will go off on one end, and that will go off on the other end, and we'll have an N, so a certain number of those joined together.